The topic of my lecture is chemical reactions taking place in the furnace during manufacturing of glass. Now, glass is a solid solution having no definite composition. However, ordinary glass may approximately be written as NO2O CaO 6SiO2, that is a mixture of silicates of sodium and calcium. When quartz or silica is heated with soda ash, sodium carbonate, the silica being an acidic oxide displaces the carbonic acid from the carbonate and sodium silicate is formed. The equation is as follows: Na2CO3 plus SiO2 gives Na2SiO3 plus CO2. When this is allowed to cool, it solidifies to a glassy mass which is known as the water glass. The name is water glass because this glass is soluble in water. The limestone, that is calcium carbonate, also reacts with silica to give a glassy mass on cooling, which is known as calcium silicate. This mass is insoluble in water but soluble in acids. The reaction equation is as follows: CaCO3 plus SiO2 gives CaSiO3 plus CO2, that is calcium silicate. Now, if silica is simultaneously fused with sodium carbonate and calcium carbonate, that is soda ash and limestone, sodium calcium silicate is obtained, which is insoluble in water and acid both. The equation is Na2CO3 plus CaCO3 plus 6SiO2, that is Na2O CaO 6SiO2 plus 2 carbon dioxide. Sometimes a mixture of salt cakes, that is sodium sulfate, and charcoal is fused with sand and limestone. Then the equation occurs as follows: 2Na2SO4 plus 2SiO2 plus 2C, that is charcoal, gives 2Na2SiO3 plus 2CO plus 2SO2. This sodium silicate then reacts with calcium carbonate and silica to give sodium calcium silicate. Now, the formation of glass is a high temperature process which takes place through a large number of intermediate stages. The nature of the steps involved generally depends upon the composition of the raw material and the temperature. The process of melting of glass can be subdivided into the following stages, and it depends upon the batch used. Now, if the batch material used consists of soda, limestone and silica, the reactions are as follows. The first of all important reaction occurs below at 600 degrees centigrade. Some moisture and small amounts of oxides of arsenic, antimony, lead and chlorides of sodium, potassium, iron undergoes volatilization. At a temperature of 720 degrees centigrade and up to 900 degrees centigrade, sodium silicate is formed by the action of soda ash on silica, SiO2. The reaction goes as follows: Na2CO3 plus SiO2 gives Na2SiO3 plus CO2. At a temperature of 900 to 960 degrees centigrade, calcium carbonate decomposes into calcium oxide and carbon dioxide. At a temperature of 1010 degrees centigrade, calcium oxide reacts with silicon oxide, SiO2, to form calcium silicate. The reaction occurs as follows: CaO plus SiO2 gives CaSiO3. Now, however, if we use a different batch that consists of salt cake, that is sodium sulfate, limestone, silica, carbon, the reactions occurs in this range. The first occurs at a temperature range between 600 to 800 degrees centigrade. Carbon reduces sodium sulfate and the reaction goes as follows: Na2SO4 plus 2C gives Na2S plus 2CO2, that is sodium sulfide is formed. At a temperature of 860 degrees centigrade, following series of reactions takes place. The first is sodium sulfate, Na2SO4 decomposes into Na2O plus SO3, sulfur trioxide forms. This sodium oxide then reacts with SiO2 to form sodium silicate. The next step is this sulfide Na2S, again it reacts with sulfur trioxide SO3 and gives sodium oxide plus SO2 plus S, and the sodium oxide reacts with SiO2 to give sodium silicate. In the next step, limestone reacts with Na2S to form mixed silicates of sodium and calcium. The reaction is as follows: Na2S plus CaCO3 gives Cas plus Na2CO3. This sodium carbonate reacts with SiO2 to form sodium silicate and gives out carbon dioxide. Calcium sulfide reacts with sodium sulfate to give calcium sulfate and Na2S. This calcium sulfate decomposes into calcium oxide and sulfur trioxide. Sodium sulfide Na2S reacts with sulfur trioxide to form sodium oxide plus SO2 plus S, and this Na2O reacts with SiO2 to form sodium silicate. At a temperature of 912 degrees centigrade, calcium carbonate decomposes into calcium oxide and carbon dioxide. Again, at a temperature of 1010 degrees centigrade, calcium silicate is formed by the reaction of CaO plus SiO2 gives CaSiO3. At a temperature range of between 1120 degrees centigrade to 1400 degrees centigrade, sodium sulfate reacts directly with silica to form sodium silicate. That's Na2SO4 gives Na2O plus SO3. This Na2O reacts with SiO2 to give Na2SiO3, and sulfur dioxide decomposes into sulfur dioxide and oxygen. Now the third possible condition of a third type of batch material which is used if it uses red lead, potassium carbonate and silica batch, the reactions occurs at 600 degrees centigrade. The first reaction occurs and Pb3O4 decomposes into lead oxide and oxygen. At a temperature range of 670 to 730 degrees centigrade, lead oxide reacts with silicon oxide to form lead silicate PbSiO3. At a temperature of 750 degrees centigrade, potassium carbonate reacts with silicon oxide to form potassium silicate and gives that carbon dioxide. At a temperature of 835 degrees centigrade, this lead silicate dissolves in potassium carbonate. Now, because of all these reactions, gases are produced. These gases remain in the melted glass and achieve a uniform heat distribution throughout the melt. These reactions also serve to homogenize the composition of the melt, which slowly progresses towards the consistency of glass. If the gas is in the form of small bubbles, seeds are said to be there in the glass. But if the gas is in the form of big bubbles, molten glass is said to have boils. The process of removing these defects is also known as refining. So these were the reactions taking place in the furnace during the manufacturing of glass. Thank you.